Hello, welcome everyone to my YouTube channel. If you are preparing for KVS, NVS or ERMS PGT physics, so this video is helpful for you. So in this video, we focus on concept clarity, PYQ analysis and some smart strategy which is helpful for you during our exam. So let us solve some PYQ with some concepts in this video. So part 1 I have already completed, which is in our channel. Go and watch that video also. So let us solve some questions. So our first question is given as the radius of the cylinder is given as 0.8 meter, and we have to find that it is rotating about with 10 radian per second, which is our omega. So the question is asking find the speed at point P. So question is asking to find speed at point P. So our speed formula V equal to R cross omega. So here R is the distance from O to P, and the question is given P is the midway of OA. If OA is the radius of the circle, which is 0.8 meter, so OP will become 0.4 meter, which is half of the radius of the circle. So now you just put here, it will become 0.4 into 10 radian per second. So answer will be 4. So here two answers are there. One is 4 radian per second, another one is 4 meter per second. So not to be confused, the speed unit is meter per second. So which is option 2. Okay. So for who are opting for Hindi, so this question is written in the Hindi form also. Okay. So let us see solve the next question. So our next question is, so this is our next question. The question is saying that in the given video, the question is saying we are given two circular discs that have same mass, same thickness, could be made up of different material. Material is different means density is different. So in order to provide rotational motion, the same amount of work is done on both the discs. So for giving rotational motion, we have what work we have to do. So the work done in both the cases are same. So it is seen that one is moved slowly as compared to others. So we have to find which options are correct. Okay, let us check. So first, as the work done is same, we can say that according to work energy principle, so their kinetic energy, which is used K1 for first particle and K2 for second particle, so both are same. So it is required a lot of space, so I'll use here. Okay, so it is as work done in both case are same. So we can say that kinetic energy for in first case is equal to kinetic energy for second case. So kinetic energy, as the body is rotating, so rotational motion, so I have to apply the rotational kinetic energy, which is half I omega. So first one for I1 omega 1 square equal to half, for this one it is I2 omega 2 square. So half I get cancelled, so it is I1 omega 1 square equal to I2 omega 2 square. But as the according to the question, let omega 1 is the slower one, so first particle is the slower one, where omega 2 is the faster one. So omega 2 is rotating with faster. So if omega 1 is slower, that means the angular speed of first one is slower. So to make this equation true, so there must be, we can say that I1 must be greater than I2. That means moment of inertia of first disc is must be greater than the second body. So take this one as first equation. So for discs, again for the question is given for discs. So for discs, the moment of inertia about its center is given as half m r square. So here m is constant for both the disks. It is given that. So I can write like mass as I can write density into volume. So as the material is different, so this density is different for both the object. So in case of volume, I can write also rho. Let as it is a disk. So disk is figure is like this type. This is type. So it has some thickness and it is a circular shape. So I can write its volume as pi r square in let its volume is t. And also question is given that both the disks have same thickness. So here I can find the value of r square, which is m by rho pi t. Okay. So I'll put in this equation. So I'll get that I equal to half m in place of r square. I just write m by rho rt. So I can here write that I is inversely proportional to 1 by rho. So I can say, so take this is as equation 2. So from equation 1, it is clearly mentioned that the slow moving object has greater moment of inertia I. So if as moment of inertia is inversely proportional to density, so we can say that if it is moving greater or greater mi, it has less density or low density as compared to second one. Clear? So if the first object is moving slowly, so it has high moment of inertia and low density, because height it is inversely proportional. If greater a moment of inertia, it has low density. That means the second body which is moving faster, the second body which is moving faster having less I, having greater or high density. Understand? Now I'll check the answers, options. So here the option is the one that moves faster is made up of more dense material, right? So this is the correct answer. We just write here the which is moving faster has high density or higher density. So clear? So we'll move to the second one. Second question, the one which moves slower has more density. Wrong. So the disk that moves faster has more moment of inertia. No. So we just prove that the which one is move faster has less moment of inertia. So this is wrong and this is also wrong. So it is option A, 1 is the correct answer. Okay. So we'll move to the next question. Our next question is, it is written here, a convex mirror of power 5D has an object or length 2 cm placed perpendicular to the principal axis, okay, at a distance of 20 cm from the mirror, and D is the distance between object and image, and L is the length of the image formed. Okay, so we have to find D and L. Okay, so it is given that mirror has power 5D, and it is written here clearly that it is a convex mirror. So as it is a convex mirror, so convex mirror is this type. So I can say that focal length equal to what we get, it is positive. So it will become like 1 by 5D. So which is because focal length is 1 by P, F equal to 1 by P. So it is in the form of 1 by 5D. So it will be, I can write it is 0.2 meter. So as the questions are in centimeter, so I have to convert it to centimeter, which is 20 centimeter. Okay, and U is given. So image distance is 20 centimeters. So image distance always taken as negative, so which is minus 20 centimeter. So now I just put the mirror formula, 1 by F equal to 1 by U plus 1 by V. So I have to find the V. So 1 by V equal to 1 by F minus 1 by U. So which is 1 by 20 minus 1 by 20. So if I solve, 1 by V is equal to, it will become like, it will become plus. So it will become 2 by 20, which is V, it will become 10. So V will become 10 centimeter. So V now become 10 centimeter. If this is my lens, sorry, mirror, this is the object, so this is the object, so image will form in this side. So this is object and this is the image. So this length is 20 and this length is 10 meter, so 20 centimeter. So total the D distance, so question is asked, D is the distance between object and image, which is this much, which is 30 centimeters. So now I got two options, which is option 3 and option 4. So now I have to find its magnification to know about the length of the image. So as you know, so magnification formula is minus V by U, which is also height of image by height of object. So just solve this one. Minus 10 by minus 20 equal to Hi by H naught O. So which is given as 2 centimeter. So put here 2. So 10 10 cancel, minus minus cancel, 2 here it also cancel. So Hi equal to 1 centimeter. So 1 centimeter. So if you check, so this is the option number 4, which is obeying our condition. Clear? So okay, so we'll move to the next question. So this is the Hindi version of the above question. So you can read from here also. Okay, so our next question is, so our next question is given as three objects, two with mass x. So this is one object, x, and this is y. One with y, arranged in the form of configuration as shown in the figure. So the following statement said that the rank of configuration according to the magnitude of gravitational force on y. So we have to find gravitational, what is the gravitational force y, or gravitational force acts on the mid object y. So we have to find individually, then we have to calculate. So for, okay, so now I'll check one by one. So for this one, if the distance are same, so for this one I can say that the gravitational force which is for option A, so sorry, for figure A, so figure A, it is the we can say the angle is 180 degree. So here angle theta will become 180 degree. So resultant force, we just directly I can say resultant force F resultant, which is FA minus FB. So direct its formula. So if I put FA is G, mass is x into y, by distance is r square. Similarly for this one, Gxy by r square. So it get cancel out, it will become 0. Okay, so Fr will become 0. So next question is, for option 2 I have to check. For option 2, is from the same direction. So it is 0 degree. So if it is 0 degree, so theta will become 0 degree. So F resultant will become like, for figure 2, so F resultant will become FA plus FB for the two case. So I can write for first one, it will like Gxy by r square. For second one, so as the distance is 2r square, so it is little bit greater, so I can write it as plus Gxy, so it will become 2r square, 2r whole square, so this will become 4r square. So Gxy by r square plus Gxy by 4r square. So for, because the for second one the distance is 2r, so if I take LCM, it will become 4r square, it will become like 5 by, so if you solve, it will become like 5Gxy by 4r square. So this is the for option 2, so which is around 1.25. Okay, so we'll move to the second question. So for third option, so third option, its angle is 90 degree. So for angle 90 degree, figure 3, so for figure 3, so if the angle is 90 degree, so I can say Fr equal to simply Fa square plus AB square. Okay, root over. So this is the formula in the resultant formula of two force. So it is according to the triangle law of vector addition. So if I have to put the same answer, so it will be like gxy by r square whole square plus gxy by r square whole square root over. So it is like, if I solve it, it will be like root 2 into gxy by r square. So root 2 value is 1.4. So 1.44 gxy by r square. So I can say this one is 5 by 4, which is 1.25 also. So 25 into f. So I have to now find the next concept. So the last one where our angle is 120 degree. So I'll solve here. So here I will solve for this third one. So for fourth one, figure fourth, so the answer is like resultant equal to FA the square plus FB square plus 2 into FAA into FB into cos theta root over. So this is the options. So I'll put the questions like the options. Sorry, I'll take the answers. So it will be like gxy by r square whole square plus gxy by r square whole square plus 2 into the same gxy into gxy. I can write directly gxy by r square into gxy by r square. So here cos theta. So here cos value, theta value is 120 degree here. So in cos, if I write cos 120 degree, so cos 120 degree value is, you know, it is minus 1 by 2. So I am directly using minus 1 by 2, minus 1 by 2. So 2 to get cancelled, it is minus. So it is root over. So our answers will become like gxy by r square whole square plus gxy by r square. So it's whole square. The minus will come here and it will be same number will multiply twice. So it will become gxy by r square or whole square root over. So the minus, so this one and this one get cancel out. So rest of the options will gxy by r square whole square root over. So which is simply I can write gxy by r square. So if you remember, for the first figure it's 0. For the second figure it is 1.25 into f, and for the third one in the above I have written it is root 2. Sorry, it is 1.44, and the fourth one it is 1. So for the figure, so question is saying, so find out if you remember, it is written in the above here all. So okay, so here it is written the third and the fourth one is 1, simply 1 into gxy by r square. So if we clear, so question is saying that which one of the following statement rank according to the magnitude of the gravitational in the greatest to least. So greatest is the third one. So figure 3, which is option C. So figure C, then figure 1.2, then option D, then option 1. Okay, so this is the options, the correct options. Okay, so next we will move to the next question. So our next question is, so it is also written in the 3 Hindi, you can read from here also. So our next question is given that an astronaut does some rough repair work outside his space station. He unknowingly leaves one of his tools outside the spaceships. Assuming orbit of species circular one, the tool will be. So when the astronaut is working on the outside the space station, so he is moving with a uniform velocity. So with a uniform speed, he is rotating around that spaceships. That means, according to Newton's first law, there is, unless until there is no external force, they will continue its motion. So we can say, according to Newton's first law, so the astronaut, if leaves its one of its tool, that 2 will continue rotating about around that spaceships. So this is option D. Continue orbiting with the spaceships unless until an external force will applied on it to stop. Okay. So our next question, we'll move forward to the next one. So question is saying the satellite orbiting an altitude of 1 earth radius above the surface of earth. Okay, earth radius above the surface of earth. So how much energy is required to transfer another orbit which is an altitude 3 radius above the surface of earth, and also what change the satellite potential energy and kinetic energy. So okay, so we have to first find its so what is the total energy required, then we have to find its potential energy and kinetic energy. So if you I'll draw a figure here, if you remember. So if this is our planet earth, so saying that the object is, or that satellite is rotating 1 radius above, that means the total distance, this is 1 radius, so already 1 radius, so total distance from center of earth is ri. So it is initially, so that's why I let ri, so it will become 2 radius of earth. Okay, so for r final how much it will become? So r final will become, the question is saying we have to transfer it 3 earth radius, so it means it is rotating somewhere in the first from the surface, it is this much, so this length will become 3r, so total will become, it is 4r. Clear? So the total become 4r, which is radius of earth. Okay, so now we have to find the potential energy. So let us bring one more page. So okay, so now I'll write here for solving this question. So question is saying we have to there is no space, so I have write here. So I have write ri, initially it is 2 radius, and r final, which is our 4 radius. Okay, so change in potential energy, if you know, potential energy will become P final minus P initial. So potential energy formula is Gmm by R. So I'll put G capital M, which is mass of Earth, small m, which is mass of that satellite, by 4 radius of Earth. Okay, so this is radius of mass. So minus, already there is minus because potential energy is in minus form. So G is our gravitational, universal gravitational constant. So mass of Earth into mass of that satellite by 2re. So if I solve it, it will minus minus become plus. So if I solve it, so I can say del P will become like G M E small m by, it will become, sorry, it will become 4r. Okay, 4re. So this is the first course answer. So it is become, yeah. So this is the answer. So now if you remember, which is acceleration due to gravity, G equal to, its value is capital G mass of Earth by radius of Earth square. So if I take GME, so it will be like GME will become small g into RE square. So I'll put here, so del P will become like small g RE square into small m, which is mass of satellite, by 4re. So re square get cancelled, it is simply become g r radius of Earth into mass of satellite by 4. So this is the value of the first one. So if I solve, I'll put all the values. So it is 9.8 into radius of Earth is 6.4 into 10 to the power 6 meter, into mass of satellite in the question it is given. So mass of satellite in the question it is given as 400 kg, and it is also radius of Earth is given. So I'll put here it is 4 kg. Okay, sorry, 400 kg. It is given like 400 kg. So now divided by 4, so it will cancel out, it will become 100. So if I multiply, the answer will become nearly equal to it's 6.2 into 10 to the power 9 joule. Okay, so now as we know in the from the gravitation chapter, so the kinetic energy will become minus of half of potential energy. So I'll put directly its answer. So it will become like minus 6.2 into 10 to the power 9 by 2. So it will become like minus 3.1 into 10 to the power 9 joule. Okay, so now the total energy required, so total energy equal to kinetic energy plus potential energy, sorry, potential energy, so which is potential energy. So if you in kinetic energy, if I put minus p by 2 plus p, so it will be like p by 2, which is simply 3.1 into 10 to the power 9 joule. Okay, so now I'll check in the options. So I got kinetic energy as minus 3.1 into 10 to the power 9 joule, and put potential energy as 6.2 into 10 to the power 9 joule, and total energy which is 3.1 into 10 to the power 9 joule. So if I check, which is option, I think, yeah, option 2. So which is option 2. Okay, so we'll move to the next question. So our next question is, okay, so our next question is given as two cylinder of copper radius. So two cylindrical copper rods A and B having diameter 0.1 and 0.05 centimeter respectively are stretched within the proportional elastic limit by 5 into 10 to the power 3 newtons. Okay, so the length of each wire is 2 meter. If the stretch is in thinner wire is 2 centimeter and the stretch in thicker wire would be. So the question is saying that simply uh, there is two wire and I have to apply the same force on both the wire, and one is radius is 0.1, another one is 0.05. If the 0.1 radius wire will stretch by 2 centimeter, then how much it will be stretched? Okay, so if you remember, so there is one formula which is y equal to, so equal to sigma by epsilon, so which is stress by strain. Okay, so it is the question is saying that simply it is stress by strain, and as we know that, so stress by strain, which is known as a modulus of elasticity. Okay, so for that I will put, as you know, stress is the formula which is known as force by area. So force by area, and simply strain is change in length, by original length. So I can write it as like if we F into L divided by A into delta L. So this is the young sorry modulus of elasticity Y. So as the question is given, both the case the force elastic proportionality which is Y is same. So I can say that Y1 equal to Y2 in both the case is same for both the case. So I can write simply as and also sorry, force is same and the material is same, so made from copper rod, so y will become same uh, because both the rods are made from the copper rod, so y will become same, so force will become same. So I can write F L because L will vary, uh, divided by, okay, so length of each wire is also same, which is 2 meter. So FL will become same. So A1 into delta L1 equal to FL A2 into delta L. So I can write simply A1 delta L1 equal to A2 delta L2. So A is the circular shape of the cylinder cross-sectional area, which I can say that it is pi r square. So pi r square, pi is also constant. So I can simply say, write that. So here it is diameter is given. So if in the form of I write in the form of diameter, it is simply pi d1 square by 4. So pi by 4 in both the case are same. So I can simply write that delta 1 by delta 2, which is a2 by a1, which is I can write d2 square by d1 square. So simply d2 is our 0.05 square by 0.1 square. Okay, so if I solve this one, it will be simply like delta L1 by delta L2, which is because I take d2 by d1. Okay, so it will become 0.0025 by 0.01. Okay, now so question is given that the stress thinner wire. So thinner one is, this one is thinner because its diameter is thin, so which is our L2. So now delta L1 will become like, so if I solve this one, it will be like 20, so it will become 0.25 into delta L2, which is our 2 the question is given 2 centimeter. So it is like 0.25 into 2, so it is like 0.5. So answer is 0.5 centimeter. So which is option 3. Okay, so we'll move to the next question. So our next question is, so if this video is helpful and this is you like the video, so then just share it with your friend, so that it will helpful for you people who it is mostly required, and also it is helpful for me to grow my channel and grow with you all people also. Okay, so we'll move to the next question. So next question is saying that we have to match the options A with option B. So first question is saying that black body. So if you remember, black body radiation is associated with Wien's displacement law. So which is Wien's displacement law, if you remember, so which is known as lambda mt equal to a constant taken as B, whose value is written like whose value is, so value of B is 2.89 into 10 to the power minus 3. Okay, so which is Wien's displacement law. So first one, and the viscous fluid, so which is known as Stokes law. Viscous fluid is known as related with Stokes law. So which for Stokes law, in which the formula is F equal to 6 pi r sorry pi r eta into b. So moving with the object, so when the fluid is moving and the viscosity is related with Stokes law, and this is the coefficient of viscosity is eta. And if you know pressure of the fluid, which is known as Pascal law, pressure of the fluid is related to Pascal law, which is force equal to pressure equal to force by area. And the last one, speed of reflex is it related with, so this one, the fourth one is related with first one, so which is Tercel law. If you remember, the formula is simply v equal to root over of 2gh. So this is related with this one. Okay, so I just take that. So this is related to A option, first A, black body radiation. So this is related to viscous, which is B. So third one is related to third C, and this is related to D. So I can say A is associated with S, so which is option 4. B is associated with R, and C is Q, D is P. So which is option 4. Okay, so we'll move to our next question. Our next question is given by, so this one is our next question. So next question is mean kinetic energy per mole of gas per degree freedom is given by. So first is mean kinetic energy per mole, I can write it as 1 by 2 RT. Its formula is 1 by 2 RT. Okay. So if I write the same, kinetic energy per mole per degree of freedom, per degree of freedom, so it is written as half kT. Okay. So energy per mole, kinetic energy per mole, so it will become like, so half kT into Na, which is known as Avogadro's number. So Na is known as Avogadro's number. Okay. So if I multiply this one, so K into Na will become RT, so which is half RT. Okay. So which is, I have written here the first one, so which is half RT. Clear? So this is this one, so which is fourth one, option number 4. So we'll move to the next question. Okay. So question is saying, which of the following graph can possibly represent the variation of surface tension of water with temperature over small temperature ranges? So if you remember, surface tension is caused by the cohesive force. Okay. So surface tension is caused by the cohesive force between the liquid molecules. Whatever the liquid molecule it has a force which is known as cohesive force. It will form the surface tension. So as temperature increases, the kinetic energy of the molecule also increases. When the kinetic energy of the molecule will increase, the particles of the surface, the bubble or water bubble will start moving here and there. That means its interaction force, as it is moving, its kinetic energy will increase. This will move here and there, so their molecular interaction force automatically decreases. Their molecular interaction force decreases. If temperature increases, kinetic energy of the particle will increase, so the particle will move here and there, so their molecular interaction force automatically decreases. If their molecular internal force decreases, the surface tension will break, or surface tension will break down. So if surface tension will break down with increase of temperature, so it is saying this graph is more representative, or a good representation of the condition which is given in the question, because in this case surface tension is increases, so it is not possible, because when kinetic energy increases, the particles are moving here and there, the surface tension molecular force decreases and surface tension will never increase. So this is, surface tension will never be constant and surface tension will never be increases. So this three condition is not satisfied, only the third condition will satisfy. Okay, we'll move to the next question. So our next question is, so this is written in the form of Hindi. You can stop and read the question if you require. So our next question is this one. So where the question is saying that, let a person whose surface area is about uh, 2.0 meters square, sitting in a room temperature of 17 degrees Celsius, and the temperature of person's body is 27 degrees Celsius, and the internal temperature is 37 degrees Celsius. The Stephen constant is given this one. Considering the person's body is a perfect radiator, the energy emitted per unit time by the person's body is approximately. Okay. So first, it is sitting in a room. So with room temperature of person's body is which is given as uh, so room temperature is 17 degrees Celsius. So first I have to convert into Kelvin. So room temperature is become 17 plus it's 273. So plus 273, which is our 290 Kelvin. Okay. So temperature of skin or the body, which is given as skin. So it is just skin. So skin temperature of person's body is 27 degree. So which is 27 plus 273, which is 300 Kelvin. So now, so if you remember the Stefan's uh, radiation, so the energy radiated per unit time, so is Q is given as the formula is epsilon sigma A whole into T skin, the higher temperature, to the power fourth minus T room to the power fourth. So this is one a lengthy calculation. So you have to solve. So here the epsilon is emissivity. So which is emissivity. So which is epsilon is 1 or for perfect body. So as the question is given that it is a perfect radiator, so epsilon will become 1. So now, so we have to put the values, and it is 1 into, and the Stefan's constant is given, sigma is Stefan's constant, which is given as this much, which is 5.67 into 10 to the power minus 8. And this is the area. We have to find the area. So here the question is given that area, surface area of the person is 2. So I have to just put 2. So now it is 300 to the power 4th minus 290 to the power 4th. It's a lengthy calculation. If you solve, so the answer is nearly equal to, you'll get 116.5 watt. So which is 110 watt. So nearly equal to, the answer is no, so which is option 2. Okay. So we'll move to our next question. So our next question is, so our next question is, so our next question is match the following. So sorry, that one I'll leave one question. Yeah. So this is our next question. So our next question is the length of a wire. So question is given, the length of a wire is increased by 20% by applying a stress of magnitude this one. So if Young's modulus of the material is given, how much? The of wire is this much. How much? So Young's modulus Y equal to simply stress by strain, which is I just write sometimes before, it is force by area by it is change in length by original length. So here the question is given that the stress of the object is already given, sigma. So stress of the object is 4 into 10 to the power 9. So you have, and the question is saying the body is increased by 20%. It means it is saying that delta L by L, which is 20%, which is I can write 20 by 100, so which is 0.2. So now you just put here, so stress is 4 into 10 to the power 10 divided by 0.2. So if we calculate, it will be like 20. So it will calculate, if it is 20, so 20 into 10 to the power 10. So if it will become 2 into 2, if it will make it fraction, it will become 2 into 10. So 4 will get cancelled, 2 into multiplied by 10, 20. So it will be 20 into 10 to the power 10. So which is it will be convert, it is 2 into 10 to the power 11. So which is this one is Newton meter square, its unit. So this one is your answer, Young's modulus. So we'll move to our next question. So our next question is, so isothermal process. So it is very easy question. So isothermal is simply PV equal to constant, and adiabatic is PV to the power gamma is constant, and cyclic process, the internal change in internal energy is 0. So so question is, A is Q, and B is P. So this one is option C is R. Okay. So it is directly given this question. Okay. So we'll move our next question. Our next question is, two vectors P and Q have a maximum and minimum resultant. So when the two vector have maximum resultant, uh, the maximum resultant in the case when the angle between them is 0 degree, so at that time, so cos theta will become 0, so value of p plus q will become simply the resultant will become p plus q. So for this one I can write simply p plus q will become 10 unit, and for minimum value cos theta will become -1, so which is 180 degree. So theta is when it become 180 degree. So in that case I can simply write p minus q will become 4. So if I solve it, simply 2p become 24, sorry, p 14, so p it is become 7 and q become 3. So now I got p and q is this much. So the question is saying that uh, the p dash has magnitude 25% less than p. That means p dash will become p minus 25% of p. So which is means 75% of p. So it means so if I solve, it is simply 75 by 100 into its value is 7. Uh, Sorry, one question is mistake I have done. So this is written as 6, so I have written is 4, it will become 6, it will become 16, so it will become 8, so this will become 2. Okay, so let's correct it. So it will become like 8. So 8, if I cancel it is in 20, 25 3 are 25 4, so 4 it will become 2, so it will become 6. So p dash will become 6. Similarly q dash will become, so q dash is 100% more than p, so q, so q plus 100% of q, so which is like 200% of q, or 2 times of q, which is I can write 200% means 100 into q value is 2, so 2 2 0 cancel, it will become 4. Now the question is saying that p dash q dash equal to 0. So the magnitude of resultant how much? So if from this question p dash dot q dash equal to 0, so dot product is 0 means the angle between p and q, angle theta, so which is, so theta between this one is 90 degree, so it is indicate 90 degree. Okay, so between the angle between p dash and q dash is uh, 90 degree. So now I have to find the answers. So resultant R will become simply p square, sir, p dash square plus q dash square root over, because angle is 90 degree. So p dash is 6 square plus q dash is 4 square root over, which is simply 36 plus 16 root over, so which is if you calculate it will be 52 root over. So 52 I can break it like 2 root over of 13. Okay, so it is the answer resultant, and you have to find its angle. So tan theta, so tan phi will become simply q component, q dash component by p dash, which is 4 by 6, which is 2 by 3. So phi will become like tan inverse 2 by 3. So so the option is, so if you look, the option is option number third. This is 2 root 13 unit, and the tan theta equal 2 by 3. Okay, so our next question is, so this video will become very long, so I'll stop this video here, and I'll solve more questions in the next video, and it will be recently. I'll upload the next video very soon. So thank you, have a nice day, and if this video is helpful for you, share with your friend, share with your group, wherever your friend, you can send it to your friends who are preparing for PGT physics exam. Okay, thank you, have a nice day.